All right, are we recording? Does it say? Yes, okay, we're recording. Awesome. So welcome everyone to Hello World. This week, we're going to be delving into Git and sort of seeing Git by example. So how to use GitHub, how to use Git, and we're actually going to rebuild a project that we did the other week and sort of see, okay, how does that, because we didn't use Git really at all during that workshop. So how would you incorporate Git into the workflow for actually building something? And like, what are some things you can do to try to avoid the pitfalls and like sort of best practices, all that kind of stuff. So if you've never used Git before, that's fine. The first thing we're going to want to do is head over and actually install it. So if you don't already have it installed, you can head to this URL. I'll put it in the chat. And whether you have Windows or Mac, Mac probably will have it installed, pre-installed. Linux probably will have it pre-installed. On Windows, you will most likely not have it. So you'll need to download it and install it. If you have any trouble with that, please put a message in the chat. I monitor it pretty regularly, so I should be able to help you with that. But the install is pretty straightforward. You just click through all the different options. With that, let's go ahead and actually start building this app. So in order to do this, the first thing that many people do, there's a few ways you can create a Git repository, but probably the simplest one is to just go to your GitHub account. So if you don't already have a GitHub account, you can head to github.com. I'll put that in the chat as well and make one. GitHub is basically a remote server that runs Git and kind of gives you a centralized place to manage all of your repositories. So if you want to collaborate with other people, most likely you make a GitHub repository that you all have access to. Many open source projects are located on GitHub. So if you're trying to install some code from an open source project, you might find it on GitHub. It's really kind of there's other services that are similar. You have GitLab or Bitbucket. There's a few others that do similar things, but GitHub is like the most widely used. So you can head there, make an account there. Highly encourage you to do that, especially if you want to follow along. But what we're going to do is just create a new repository. So if you click this new button, or I think if you go to this plus, you can do it as well. But you just want a new repository. So click that. We'll make a new repository. We're going to be, again, rebuilding this weather app. And I think before I called it weather app improved. So we'll just call this weather app improved 2. Public project is fine. If you want to make a private project, you can change that and then only you would see it. That's fine. These steps, usually you don't need to check any of these. You could kind of read about all the different options, but if you just want a plain old blank repository, then you're good to just go. So click the big green button and you'll see it create a repository. So your repositories will always be at this link. It'll always be at github.com/your username / whatever your project name is called. So that's a handy thing to know. That's also going to be the link that we are able to grab this from. So if you go here and kind of grab this, copy this link here, then you want to open up your terminal. So if you're on like VS Code, you can use the integrated terminal. If you're on Windows, Git Bash is a thing you can do, or you can just open up the Mac terminal. If you're on a Mac or Linux, you can open up your Linux terminal. But basically, you're going to want to paste that link in and run Git Clone. So what clone does is it basically just copies down a project from GitHub or some other host to your local machine. Okay, it's warning us we have an empty repository, but that's fine because that's what we expect it to be. And the nice thing about setting up your project from GitHub and then cloning it down is it handles connecting up all of it handles connecting GitHub to your repository without you having to sort of manually do it, which is really nice. You can do that, but if you have the option, this is probably the easier way to go. Okay, so now you want to go into that folder. You can use the cd command, change directory, look around. There's nothing in here right now. So in order to actually set up our project, if anyone's here from last week who remembers, we used create React app. So you can run this with npx create React app and then dot. We're going to be seeing this a few times tonight, but the dot character just stands for the current folder. So this is what this is going to do is create our React app in our current folder, so we can run that. In order to do this, you will need Oh, we don't want to support. Okay, in order to do this, you will need npm installed. Oh, they don't want us to do it this way.
That's a thing. It was pretty annoying. I recently encountered that.
Yeah, that's interesting. You no longer. So what do they want us to? What do they want us to do? Let's see what they want us to do. This must be a recent change.
Yeah, it's for the newest subversion. What they want you to do is remove or delete your current version of Create React App. Yeah.
Okay. I think I recommended this as a workaround before, so I guess now you just have to have the latest version of npm. Okay. Yep. So we'll go ahead and run this through. Thanks, Arjun, for the filling me in on that. That is like a brand. That must be a brand new thing because like this worked as of like 2 weeks ago, a week ago.
It's pretty new because I was working on a weird React app I was making, like a meme, 3 days ago, and it was fine. And then I had to create another one 2 days ago, and it stopped working.
Gotcha. Yeah, that's pretty strange, but it's because npm changes a lot of things, so you kind of just have to deal with that. So this should take a minute or so to run. Again, this is not a React workshop. We're just going to kind of use this as an example of a project. So this could be any project. You could have an Angular project or could be on the back end. This could just be even like code for your classes. I often make Git repositories for code I'm working on for class. It's not Git. You can even do like text files. Like I've done notes in Git before. Any basically text files you can track with Git. The idea is just to be able to have like backups of all of your, that way, like if something goes wrong, you can always roll back to an old version. And it also gives you some kind of powerful collaboration tools as well. So especially for code, it's more useful for code, I would say. So Create React App is actually pretty great. It automatically will set up a, it should, I believe, set up a Git. Oh, you know, it didn't because there was already one set up. But if you create a new folder with Create React App, it will create a Git repository for you. Probably our favorite command tonight is going to be Git Status. So this is a great command to run whenever you're not really sure about what is happening. And it'll give you some information about like currently like what Git thinks is going on. And also usually it'll give you some suggestions that are a pretty good idea. So when you first initialize your Git repository, you have no commit. So if we run Git Log is the way to look at all of our commits. A commit is just a snapshot of your project. And so we just created this, right? So we don't have any commits. There's no snapshots. Nothing is saved, right? If we go up to GitHub, we just have a blank repository, right? These are just trying to give you instructions on how to put something in your repository. So how do we actually create a commit? Well, what you need to do is run git add. So there's a few different sort of areas that in Git. There's stuff that's already committed, and that usually doesn't show up. Then there's this untracked files. So if you have like a colorized terminal, it should show it in red. And then after you add things, it will turn them green. So you can now see, so what I did is just run git add and then the name of one of the files. So it sort of shows you all the files that have been created, but aren't tracked by Git. That's why they're untracked here. And so if we add like this .gitignore file it created, right, git add.gitignore. So we just put the name of the file, then change it to this green and changes to be committed. So this red is just stuff that has changed. The green is, okay, we're getting ready to actually take a snapshot of these things. This is useful. We might use this later because sometimes you make a bunch of different changes and you only want to kind of include certain ones of those changes. And so you might want to add one file, but not another. But generally, you want to add all the files. So there is a quick shorthand to add all the files. And that is with this dot. So if you run git add dot, remember in your terminal, dot stands for the current folder. So we'll add everything inside of our current folder, which in this case, since our whole repository is in this folder, that should add everything. And so you can see it does. So these are all the different things. If you're wondering why there's more, it's just because this public folder, and now it's adding each of those items individually that are inside that folder. And same thing with our source folder. It's adding all those individual items. So once you've added all of that, you can type the git commit. So this will take a snapshot. This is just sort of our initial snapshot commit to set everything up. there's sort of two ways you can run it. The first way is to use the -m flag. So if you use this little -m, then you can put a message, it'll be your commit message. So a common message would be something like initial commit. This is one way to do it. The other thing, and this is what I usually do, is just run git commit without the M. And then it will open up your editor and let you write a commit message out in your editor. So it'll also give you this like nice long comment with all the things that you added to sort of remind you. So this is what I usually do, but you can do it either way. Some people always do it the other way. It's just up to you. So usually the first commit is called initial commit. So you just say initial commit. And then go ahead and save and quit that file that it opened up. And you can see, okay, it made this initial commit, 18 files changed, 38,000 insertions. That's great. So Create React app creates a lot of stuff for us already. And now if we take a look at the Git log, you can see there's a commit that's been made. So there's a few parts of a commit that are important. There's this commit hash. This is like a unique identifier that represents this commit. So it's a way we can reference this commit from anywhere, which is nice. It also includes some author information, the day you committed, and then also your commit message. So that's great. There's also this head arrow master. We'll talk about that later. But for now, we have that committed. Let's actually take a look at, so in order to actually start this project, you can run npm start. Let's actually take a look at what this currently looks like. So we just sort of have the default React project. When it loads up here, this is just sort of React gives you by default. And that's great. If we want to actually start to change this though, we're gonna need to head back to our terminal. So can you see both at the same time?
Yeah, you're good.
Okay, cool. So what you want to do, one nice thing about Create React app is that it will like hot reload this for you anytime you make a change, as long as you leave this command sort of running. So if you open up a new terminal or just open up your editor and navigate back to that folder that we were just in, then we can start to make changes. So the main changes we're going to make tonight are just in this source folder, and we're going to edit app.js. Most of this other stuff is not too important. So this is sort of our basic app here. You can see some of the things, this edit source/app.js and save to reload. That's the same one that's here, right? So if we actually edit that, it will change. So let's make an edit. Let's just do hello world. And maybe delete this image. We don't really need that. We can remove the import for it. Okay, so you can see it reloaded. We've got hello world, and we can get rid of this link to learn React as well. Again, this is not a React workshop. So if you're interested in learning React, we had a workshop for that about a week ago. So you can take a look at that on our YouTube. Okay, so let's say we made these changes and we're happy with that. Just to start, let's go ahead and do that. So we can run Git status and sort of see, okay, what does Git think about this? So Git's always going to tell you what branch you're on. So in this case, we're on the master branch. You can also see this sometimes called main. There's a couple of different things it can be called, but usually you see either master or main. There's some information here. We'll fix this in a minute. And then we get this red again because Git noticed we made a change. So anytime you make a change to any file in the repository, Git will notice, and then it'll move it as part of the red. And so if we want to actually add that change, we can git add app.js. And if we run git status, you see it turns green, so changes to be committed, and then git commit. Yes, so if you just run git commit, Ricardo, if you run git commit without that -m flag, so, oh, sorry. If you run git commit without that -m flag and a message, like, so here, we'll do this commit like this just to show how this works. So this message might be remove React default stuff. All right, that's another way you can do it. Some people like that better. I'm just in the habit of typing git commit and then letting the editor open up, but it's 100% up to you which one you want to choose. If you do just type git commit, it will open up whatever your default editor is. So in my case, that's Vim. That's the editor I use. But if you have your default editor set to VS Code or Sublime or Atom or whatever, then it should open up a file in that. Okay. So what we've done now, if we can actually check the log, and see some things have changed. So here's our initial commit, still there. But now here's our new commit where we remove the default stuff from React. Head always points to the current commit. So if you've taken like CS1, head is a pointer. It always points to the current commit. So in this case, this happens to be this latest one we just added. And then master also happens to be, because we're on the branch master. So right now, since we're on the master branch, any new commits we make will always appear. Master is also going to move with head because this is the only branch we have. We will make another branch at some point later tonight, and you'll get to see sort of what happens when you do that. But for now, we just have the one branch, and we're currently on that branch. So head and master always stay together, and they move to the commit we're currently on. Something you want to do periodically is push your work up to the server. So this right now, what we've done has only happened on a local level. You can do all of this without an internet connection. And if we go back to our app here and kind of like reload and like, look, do we have any code? We still don't have any code, right? There's nothing here on the server. That's because Git doesn't automatically synchronize your local work to the server. So if you want to synchronize, if you want to get code from the server that someone has added to the server, there's a command for that. If you want to take your local work and put it on the server, there's a command for that as well. So that's what we want to do right now. Let's go ahead and push up our work. So the command to move your work up to the server is called Git Push. There's a couple things you need to do, but I rarely remember how to do this. So I just run Git Push and it will fail and tell you what to do. Git's very nice about that. Or, oh, okay, in this case, it lets you.
Well, it's because you committed.
Yeah, no, usually I set up my repositories the other way and it gets mad. Okay. Yeah, so then this is one great reason to do it the Git clone way. If you set it up the other way, if you have questions about that, you can ask me at the end. I'll show you how to do it the other way. But if you do it the other way, you have to do some more manual work to get it working. But yeah, so now we've done a push. So let's actually take a look at GitHub. So now if you look, GitHub has all the same things that we have. So if we kind of head back out to our main directory here and look around, we have a README, node modules, source, public, package.json. Okay, and if we go to GitHub, look, GitHub has all these same things. And that's great. And also GitHub has our commit. So if you look we can look on GitHub and sort of see these commits. That hash will be the same thing as before. You can look at the commit and see the changes that were made. It's very nice. Okay, so we've pushed up our changes to the server. That's great. So let's go ahead and make some more changes. So the next thing, moving towards like actually getting this to look nice. Let's see. We probably want to remove the rest of this stuff. You know what I did next is actually we need to install Material UI. So Material UI is just the library, is a UI library. Again, nothing to do with Git. It's just a package that sort of provides some pre-made components that look nice. Okay, so we installed that. Now, after we installed that, this would be a reasonable time to commit. So I tend to commit fairly often. There's different approaches to when you should commit. I tend to commit very often, and then you can always fix it later. And I will show you how you can fix it later if you realize you committed too often or you want to kind of combine some of your commits. It's much harder to take a large commit and then chop it up after the fact. So it's always better to commit more. If in doubt, you probably should just commit and then you can fix it later. So in this case, when you install a package, it kind of updates these package lock and package.json to sort of track that you installed it. So we can add those. I'm just going to do the quick add. And then we can run Git Status, right? You see it's green. So you should always see red, then you add, you see green, and then run Git Commit. And so I'm just going to do add Material UI. Okay. One thing of note, I see a lot of people do this wrong frequently. There is a style to how you're supposed to write your commit messages. So you should always write them in what's called the imperative tense. And basically what that means is you should always sort of think of it like if you read the following words before your commit message, the grammar will tell you if you did it right. So I always, anytime I make a commit, you just always should think this in your head. Think this commit will, and then try to read your message. And if it makes sense, you've used the proper tense. But like sometimes you'll see people use the past tense, and that's not correct. So saying you added material UI or, you know, fixed the bug, right? These aren't good commit messages. At least they're not in the standard style. Because if you read this commit will fix the bug. It doesn't make sense, right? So you always want to use this imperative tense. This commit will add material UI. That's grammatically correct. It makes sense. And so that's how you know you're writing the message correctly. And it's a small thing. I mean, of course, you can put whatever. You can just put, you know, a number or a dot as your commit message. But you always want to make sure your commit messages have descriptive names. That way, when people look in the log or try to figure out what went wrong later, the commit messages will actually be helpful instead of just, otherwise there's no point in using Git if you don't have helpful commit messages. Okay, so we're going to make that commit. That's great. You can see it should just be add. I mean, because if you think about the tense, right? This commit will adds material UI. Doesn't sound right. At least it doesn't sound right to me. It shouldn't sound right to you. I guess you could. Usually I just use git commit. I just use add, this sort of the singular tense. Again, if you say it's, but you want to say will. That's what sort of what gives you that tense. So this commit will. So this commit will. Well, the initial commit is an exception. That one's just usually always called this. But you'd say this commit will remove React default stuff. This commit will add material UI. It doesn't make sense to say this commit will adds material UI. Again, that is a style thing. Some teams and organizations don't follow it, but that is the default style. And I encourage you to use that because most projects use that. And you'll seem like it's just a good sort of professional Git practice, the proper practice if you're trying to use the best, but it's not a huge deal. All right, let's take a look at this log. That is not super duper important. Let's take a look at this log. So you can see a few things have changed. Our log now includes this mysterious thing called origin. Origin is the server. So in this case, that's GitHub. It could be a different site, but in this case, it happens to be GitHub. Usually it'll be GitHub, but it could be whatever host. You can self-host Git servers. So if if you're afraid of GitHub, it's owned by Microsoft or whatever. So maybe you're like, oh, I don't trust that. I'm going to make my own GitHub. You can. It would take a lot of work, but you can do it. And then origin would be whatever your server is that has Git on it. So origin is GitHub. And so you can see, okay, GitHub is still here on this removed React default stuff. And if we go to GitHub, you'll see that's the case. So remember, Git doesn't do any automatic syncing. All right, so it's still here. The latest commit is still removed React default stuff. Until we do Git Push, all of your changes are only on your local machine. It will never automatically synchronize it for you. You'll always have to push. My editor kind of reminds me to do that by having, or my terminal by having this little arrow. But if you run Git Status, it also will tell you to do that. So say, look, your branch is ahead of origin /master by 1 commit. Use Git Push to publish your local commits. So if we do that, push that up. And now if we go to GitHub, you can see it has the add material UI. Okay, so that's that. We've added material UI. Let's actually take a look at adding some components here to make this look a little bit better. So let's get rid of all this default stuff. What we're going to want to do is import some things from material UI. So the first thing we want to import is our button. So if we take a look at our site, we actually have this clickable button here, right? We need that to work. We also need this sort of text box. So let's import those things. Basically, those are button and text fields. Okay, so we import those. Now, usually I will not make a commit for just an import. So a commit, I feel like, should be a cohesive set of changes that actually moves things forward in some way. So in this case, just importing, that doesn't really do anything. Like you can see they're unused. And we delete that stuff. We do need to put something in. So let's go ahead and do that. So Let's add a button, and let's add our text field as well. We also may need to wrap all of these. React only likes you to have, this is a React thing, but React likes to have only one component return. So you just wrap it all up inside of a div. Okay, so let's take a look at what that looks like. Okay, so we got our text field. We didn't get our button because the button needs to have something inside of it. So put something inside of our button. Take a look at that now. Okay, so we have a button. Oh, I don't like that transparent color. So you can also set the color. Something more interesting. See if did that do anything? Not really. No, that's kind of interesting. You made it sort of pink. You know, maybe that yeah. Maybe that didn't properly load in. But so what you should definitely do is during your commit process, make sure that your current commit actually works. Like, don't just commit things. You should test and be sure that it actually looks okay. Let me take a look and see what I actually did the other day to make this look good. Okay. We need to add variant equals contained. Oh, much better. Okay, so now we have that. We also can put everything inside of a box here. So box is another material UI element. And we can add sort of a margin to give us some space around all of this. Okay, so that's good. We have some space. We have a little thing. I think it would look better if these were reversed though. So let's do that. Okay, that's pretty good. So let's say I'm happy with this set. Now I feel like this is a pretty good set of changes. We now have it sort of displaying in a nice way on the screen. That pink is kind of bright though. Okay, that's a little bit better. We have it sort of displaying on the screen. So this is a good time to go ahead and do a commit. And again, if you're ever unsure, like, oh, should I do a commit? If you've made significant progress, like even a little progress, it's probably a good time to do a commit. And I will show you how you can combine your commits later in case you decide that, okay, I don't really want to have a whole commit for all that stuff. So let's do our git add dot, run git status. Okay, do our git commit. Okay, so in this case, let's see, add. So this commit will add button and what was the other thing? Oh, a text field. Okay, so save that. Well, we can push it, but no need to push for now. You don't need to push every time you make a commit, and there are reasons why you don't want to necessarily do that. You should push on a semi-regular basis, but not. I wouldn't say do it after every single commit. Okay, so we have this sort of set up. The next thing we need to do is set this up so that we can read this value here. So in order to do that, we need to basically set up a React controlled component and some state. And again, if this is all unfamiliar, this is not a big deal for knowing Git. This is just sort of React stuff. We do have a workshop on this, so you can watch that. All right, so let's see. We can use text. This is sort of the way you set up a form in React. So what you want to do is set the value of the text field to be whatever the current value is. And then you want to set an onChange handler. And your onChange handler is just going to take in an event and then set the text to be, I believe it's event.target.value. Unexpected. Oh, we need an equal sign. Okay. So we have that. Let's check and see if that works. Types, okay. And something else we can do, let's check and see if, let's log out that text to make sure that it actually is saving into the variable properly. So if we, okay, so it is. So you can see that as I type different things, it's logging the value and it's changing. So they are bound correctly together. All right, so let's go ahead and commit this. So we can just say add text field state. Usually add is a variable, add is a verb, I think is very good. There's some other ones you can do, but add is the one I use most often, especially because you're making additions, right? If you're deleting things, then you say remove, but okay. Oh, so something I noticed. Usually you don't want your debugging stuff to be in the actual commit history. So I accidentally committed this console.log. Okay, so what can we do? How can we fix this? If it's on the commit you just made, right? Because it's in that commit. So it's in right now, this text field state that was added in because I added it. I forgot to remove it before we committed. So if I want to remove that, there's a few things you can do. You can just delete this and make a new commit. So you can do that and then say, okay, remove console.log. That's one approach, but well, we can do that first. The bad part about this is it will leave commits. If anyone ever tries to go back to this commit, they're going to have the console.log, which is sometimes like if you have like comments of things you're supposed to finish, or this comes up often, like you commit something by mistake and you realize, oh, I left in some things that need to be removed or some comments that need to be reworded or whatnot, or you just find a small bug later while you're working on like the next thing and you're like, oh shoot, that should have been, I made a mistake in the last commit. So you can have multiple commits, but the best thing to do is to sort of combine it together so that it's impossible for someone to check out a bad snapshot, right? You want all of your snapshots. It's like, think about if you're doing backups, right? If you're backing up your hard drive, you don't want one of your backups to just be randomly like broken and not have all your files or anything like that. You want every single one to be a good one. So if you make a bad one by mistake, then you need to fix it. So if you've already made the commit, then the easiest way to do this is to, if you haven't made the commit. So you wouldn't want to do this in this case. So what you can do if you've made a mistake and committed something you didn't mean to commit is reset yourself back to the last commit you were happy with. So if we want to say, okay, I didn't mean to commit this, let's go back to here. So you can just copy that and get reset to that point. You don't have to type the whole thing. Like if you get enough characters that it doesn't match any of the other ones, it'll be fine. Okay, so let's do that. And then what it will do is it'll pop all of your changes you made back into red. So before it was committed, now we can go back and see, right? You see the little minus over here, so it shows I deleted that line. So we're back to where this is here. Yeah, okay, Michael brings up a great example. If you've committed like your access key for your whole database or something, and like this happens all the time, like I routinely run into this. So if this happens, if you need to take off, that's fine. If this happens, then what you should do, if you haven't already made another commit, then go ahead and add that. So add your fix. And then instead of running commit, you want to run git commit -- amend. And what this will do is it will merge it back into your previous commit. So notice, look, the commit message is already populated with add text field state because that was what the last commit was. And it has all of the other changes we made, except look, you see the console.log? It's like it never actually happened. And this is what we want because we don't want anyone to know that we accidentally committed that or that we put the access key for our company database into Git by mistake, right? And so now it's all fixed. And if we look, like if we're still on this commit, it's just fixed up now. It doesn't have the problem anymore. So that's great. So yeah, git commit amend, fantastic. I use it all the time. All right, so let's keep moving forward on this. Let's see, what's the next thing we can do? So we have that working. What we really want to do though is we need to fetch data from our API. So let me go ahead and grab some of the API URLs that we'll need. Go ahead and add that. Okay, so this is our sort of first URL we'll need in order to fetch the all the list of cities from our information. So set up that. Our button we need to set the on click to be this function. Because when we click, we want to go ahead and actually fetch this data. And when we fetch this data, we're going to fetch this URL because this is our API URL, and then whatever's currently in the text box. Again, don't worry about this too much if you're not familiar with React. Not a big deal. The point is, for this, we're just going to go ahead and fetch some data, and let's log it out to make sure we got it. Okay, so all right, so you can see, maybe you can see, hopefully you can see down here, we got an array back with all of those places. So like New York, New Delhi, New Orleans. Okay, great. So we actually are getting the data. We could commit here, but I think I'd like to actually get it to the point where it's actually displaying something. What we're going to do for the first iteration is just grab the very first element of that off. So we can set our city equal to data 0 because data is an array. Let's make sure that works. And okay, yes, we are grabbing this object in title. Okay, New York, that's great. And then in order to actually get the more expansive weather data, we need to grab this WOE ID. So we can log that out. Yeah, so let's log that out, make sure that works. And then let's actually go ahead and add the other fetching as well. Let's just add all the fetches in one commit. Okay, so got that. Okay, our other URL is basically just the same, but without some of the things at the end. So we're going to do another fetch. So fetch our weather URL and then add our ID there. And let's go ahead and log. Let's go ahead and log that out as well. Again, these could be any changes. Doesn't have to be this stuff necessarily. All right, so let's run that. See if this works. Okay, so great. We're getting back our weather, and we can actually go ahead and print out. Let's grab this first. Well, this is actually pretty good as is. So let's go ahead and just commit this. Or here, I'll show you the other way to do this, so you can sort of see that. So let's go ahead and commit this. All right, so we commit this again. One thing I encourage you to do is you can run, before you run git add. So if you run git diff, it will give you a sort of text readout of the changes. So this is a great way to try to catch like console, like print statements or debugging stuff or to-dos or anything that you left that you were like supposed to do before you committed, but you forgot. If you run git diff, it will give you kind of some pluses and then the things that were added and then minus with things that were removed. So you can sort of see, okay, these are the changes that were made. It's a really cool feature. Running a diff is a good idea, especially if it's a larger commit. You know, you want to make sure that you did everything right. So that gives you a quick overview. So let's add it. Let's commit it. Okay, so add fetches. City and weather fetches. Okay, so we have that. So now let's say that I realize that I want to, here's the other way you can, actually, let's just make some more commits and then come back and fix it, because the git commit amend is great for something you just forgot to do. But what if you forgot something like a few commits ago and you're like, oh no, like how can I fix a commit from like a few commits back? So let's say we meant to remove this console.log, but we just forgot. And for now, let's just keep ignoring it like we didn't notice. Okay, so the next thing we want to do is get a card and sort of print out some of this data. Because like here we want to, why don't we try to get light rain printed out? So if we grab this, if you want to actually grab that data, so weather, it's just going to be that weather data dot consolidated weather, because that's the name of the object that the API returns. And then we want to grab just that first day, and then the weather state name out of that. So if we log this out, let's make sure this is the right thing. So run this. Okay, and we're getting that logged out. So that's great. So now we should be able to actually display this. The way I'm going to do this is to use a card, but there's different ways you can do it. Card, I think, is pretty for this use case. So you also need something called card content to actually put stuff inside of your card. Okay, so let's go down here, add our card, need our card content. And then inside here, we want to put weather. We also will need some more state to hold our weather. So we're going to get that, we're going to get the weather and then set it into our variable and then render that inside of our card content. So this should work. Let's see, take a look and see how this works. Yep, so you can see sort of our little card object here. If we look something up, there we go. Okay, now it displays into there. Okay, so this is pretty good progress. Let's go ahead and add this. So you can do the dot. I usually do the dot, but you can also just add individual files. Don't forget about that, because sometimes you only want to commit certain parts. Okay, so add card component. Oh, that's not spelled right. Okay. So we've made several commits now. So what I'm about to show you, I'm about to show you how to go back and fix a commit from several commits in the past. If you've pushed, you should not do this. And this is probably a good time to bring up another site. So let me, can you all see this? This site I found the other day and is great for sort of visualizing. I'll put a link in the chat. Great for sort of visualizing how your Git commits are working. And so what I'm about to show you is how to do a rebase, but what it will do is rewrite commits. And this is, you're actually going to rewrite history to look like something different out. That's what we want to do, right? We want to make it seem like we never actually put that console.log at all. But this will cause major problems if anyone else has access to that history. So Git Rebase it's kind of like a conspiracy. Let's say that I want to make a conspiracy to convince everyone that the moon landing was faked or something. In order for this conspiracy to actually work, we need to get basically everyone in on it, right? If anyone in NASA or anyone who's involved with the project, or the people who did the okay, conspiracy is in everyone needs to agree for this to happen. So if I'm trying to, let's say NASA really did fake the moon landing, okay? How would they do this and actually be successful at tricking the public? Well, everyone who's involved needs to all agree to say that the moon landing was real, even though it wasn't real. Rebase is the same way. Everyone needs to agree to change history. So if you decide that you're just going to say, hey, you know what? I think that console.log was never there, but you don't tell other people about this, then it's not going to work out. You're going to have big problems. Just like if in real life you try to claim that it's just like, say one person in NASA tried to claim that the moon landing was real, but everyone else said it was fake, right? Then it's not going to work. You need to get everyone in on it. Everyone needs to agree to change history. So let's actually like sort of visualize what this actually is doing. So if we let's add, so what's nice about this is you can just sort of add commits and see how things change. So let's say this commit right here, this F9.6 commit, this is the one that we want to revise and make it seem like something different happened. So we've added some more commits since then, right? So how do we go back and change this? Well, the first thing we do is make a new commit that has our fix in it. So what we want to do is, well, first what you want to do is, I guess, I don't know if this actually has the command I want. Does it have interactive rebase? No. Okay, it doesn't. But you can still sort of see what will happen. So first what you do is make a new commit that has your fix in it. So this commit right here, this one that's currently green, that's our fix commit. We want to go back and patch up this one. So what we need to do in order for this to work is rewrite these last 4 commits and take this commit and merge it together with this one, and then reapply these 2 commits. And these 2 commits, you might think, well, their changes didn't really change. They're the same, right? But every commit's hash has built into it whatever the parent was. And so if the parent, like if this commit changes, then this commit has to change as well, because it's being applied onto a different snapshot, right? If you go back and change one of the snapshots, then all the snapshots that are based off that are going to be slightly changed just to include that change. And so all 4 of these have to be changed. Now, the problem that this is totally fine to do. The problem that comes up is if this is already pushed. So when you do git push, okay, here's what happens. So this is origin. Origin has its own, this is Origin's timeline of things that happen. It's the same as ours, right? You can see, I don't know why it did this weird side arrow like this, but it's the same, it's all the same commits. If you change these 4 commits, but they don't change on origin, then your changes will no longer, if you try to push your changes, Git will reject it because the history doesn't match up, right? If you have 2 different histories, Git doesn't know what to do, and it'll completely quit on you and give you a bunch of error messages, which would be really bad. And so this is why if you want to be able to do this, and if someone else has this, like let's say someone else has downloaded these changes, then like there's basically no hope. You're not going to be able to change history, because if someone else has access to your changes, then they might have a branch of this, and then it could cause problems. So you don't want to do it. So the rule of thumb is only rewrite history, like do git commit amend rewrites history. It takes your current commit and then melds it into your last commit. So if we try to do git commit amend here, actually it won't let me do that because it won't actually open up the editor. But if we try to merge these 2 commits together, now we'll have a new commit here, but the origin will still have these 2, and there's no way to sort of reconcile that. So never rewrite history that has already been pushed up. And so this is why I encourage people not to constantly push things up all the time, because all of these commits, origin knows up to here. So we can't rewrite any of these commits without causing massive problems. We can only rewrite these ones because these are ones that only we know about. Okay, so what does that actually look like? The way to do this is to run git rebase and then the -i flag, which is interactive. Interactive rebase is really great. Probably going to do a whole workshop on it. But this is just sort of like, if you want to go back and change something that happened and you haven't pushed, this is how you can do it. And then you need to specify how far back you want to go. So in this case, we just want to be able to manipulate all the commits all the way back to origin/master. Before we do this, though, we need to actually add our commit that adds the fix. So let's do that. So add that change, right? So I'll just call it like fix. That way it's nice and clear. So now we look at our log. So let's do our rebase onto. So we're going to rebase all of the commits back to here. And so now you get this big long comment that tells you all the things you can do. So what you can do inside interactive rebase, it'll open up a file and you can reorder your commit. So let's say you wanted to say that this happened before that. You can, which is cool, although we don't really care about that in this case. You can merge commits, you can delete commits. If you wanted to like, hey, I wanted this commit to just never have happened. You can just delete the line and it's gone. It never happened. So that's pretty great. But for now, what we want to do is pretend like this fix happened back here when we originally added that state. And then we want it to be part of that commit, right? Because we don't want there to just be this fix in the middle of the history. So you can actually look, there's a whole bunch of options here. But the most interesting ones are the squash and fix up. They're basically the same. What squash will do is keep both of the commit messages. And fix up will do the same thing, but it will drop the message. So usually fix up is what you want, because then it makes it seem like that commit was never there. So what's going to happen is this commit is going to be unchanged. This commit is going to have our fix merged into it. So it had the console.log, but it's going to merge in this console.log that never happened. And so then it's going to look like that never happened. And then it will try to reapply these commits on top. So if we save, you might get a conflict. So a conflict happens when Git is unable to automatically apply some changes. So it's not too concerning though. What you need to do is run Git Status, right? So we'll see this with merge later as well. So if you're doing merges are more common. Rebase is kind of a nice thing to fix your own history, but merges are more common and you can also get conflicts. So what you want to do is run Git Status and it'll tell you what's going on. So we're doing interactive rebase. And so it actually tell you what to do. You need to, your current fix conflicts and then Git rebase continue. So in this case, anything in the red is going to have problems. So let's go ahead and edit that and see what's wrong. And what happens is you get these conflict markers. So this head, remember head is where we currently are. And we're in the middle of applying these commits. So if we actually look at the log right now, right? Basically how Git Rebase works is it backs up time to here and then starts reapplying these commits one by one. So we're right here after we added the text field state and the fix already happened, it got merged in. And so that's where we are. And so after we've done that, this fetch stuff shouldn't be here. So we can get rid of that. And this is basically what we want it to look like. And then save that, add that, Git Rebase, continue. Again, this is a more advanced technique, so don't worry too much if that confused you. But I know there's some people out there who want to see some more like fancy stuff. Okay, so now if we look at our log, though, it looks like that fix was never there. And if we actually go back and check out, if we want to go, so checkout is a way to just go back temporarily somewhere. So if we want to go back to this commit, or it was the text field state one, go back to this commit and we open up that file, the console.log is not there. So history looks like that literally never happened, which is cool if you made a mistake like committed a private key or something that needs to not be accessible. Okay, so if you want to get back to just sort of the main master, you can check out master and that'll take you back to where you are. At this point, I feel pretty good about this, so let's go ahead and push. But remember, once you push, don't do rebase, because it will cause big problems and you just don't want to deal with that. So that's why you should maybe defer your push every now and again. Okay, don't need this anymore. So if we take a look at this, we have this working pretty well. You can click that and then get eventually get the weather. That's nice. It would also be nice if we could print out sort of the temperatures. Okay, so let's work on doing that. Now let's go ahead and see how to use a branch. So when you're working alone, branches aren't super helpful. But if you're working in a group, branches can be useful to have sort of multiple different levels of development going on. If we open back up let me open back up that. Let's open back up that site just so you can sort of see what a branch looks like. So a branch is, the reason it's called a branch is it's literally like a fork in the road. So what you do is you type git branch and then the name of your new branch. So I don't know, let's call this like improved weather description, maybe. That's kind of a long branch. So improve description. Okay, so notice what happens. When you run git branch, almost nothing happens. It just creates, remember, head is a pointer that points to the current commit. Master is a pointer that points to whatever the most recently committed thing is. So like if we git checkout, like B7, oh, what happened? Oh, it went back. Okay, if we run git checkout B7, so if I check out this commit, the head pointer moves. Head is where you currently are. Master is always the last thing that was committed on that branch. It's a branch, so a branch just points to whatever was last committed on the branch. Head is literally where you are. Usually you are on the latest commit, but sometimes if you want to go look at an old version or something, you can check out into the past if you want to. Let's go ahead and check ourselves back to master. Okay, so what's interesting about a branch is only the current branch will move when you make a commit. So if we make some more commits here, if you look, okay, head keeps moving, master keeps moving, but look, improved description is still sitting back here. So it's like you can think of it like a parallel sort of timeline. It's like these changes here that are on the master branch, part of the master, because all of these three are part of both. These three are only on master because improved description stopped here. So if we head back to improved description, master will stay up there, but now our head, where we currently are, is improved description. And if we make different commits on improved description, this is where you get the idea of an actual branch. So now we have like sort of a real branch. So you see what's happened? Master has these three commits. It has this sort of set of changes. Our improved description has these other set of changes. And this frequently, like as one person, this usually doesn't come up much. But if you have a group, this is a huge deal because now you can have some people working on this improving the description and other people working on, like, let's go back to master. And maybe someone else is going to make some, button improvements. Oh, you also need to actually create the branch before that will work. Okay, so we make a new branch for button improvements. There we go. And then check out that branch. And then add some commits to that. Okay, so this is our history. And you can see, let's say, okay, we can go back to improved description. So it's literally like two different realities. And if you actually look in your folder when you do this, you'll see the files change after you do the checkout. Git will just magically swap them out. So let's say you've had these two branches running for a while, right? So you have master, which is here. You made some button improvements. Okay. But eventually, the idea of branches is that eventually, like you can work on these things separately, but eventually you're going to want to combine your work back together into like the real main version. And usually the main version is like master or main or something like that. So let's say we want to add these changes back into master. How are we going to do this? So there's sort of two main cases. The first case is this very nice case. So button improvements. If we look at button improvements, it's strictly just an upgrade of master, right? It's the exact same history as master up to here, and then it just has 3 extra commits. So if we wanted to update master to have all the changes from button improvements, all we need to do is move the master pointer to where the button improvements pointer is. And so the way you do this would be with a merge. So this is what a merge actually does. So if we check out, let's go to master. Okay, so now we're currently there. So check out the branch you want to merge into. And then you type git merge with the branch you want to get commits from. So we're on master, we want to merge in the button improvements. And so when we run this, it will do, see right here, you've performed a fast forward merge. It's called a fast forward because it's very fast and all you do is you move forward. You don't have to do anything special to make this work, right? Button improvements was strictly just improvements on the current master. So that is the happy case. You hope this happens every time, but eventually you'll get to a case where this doesn't happen, because while you merged in those button improvements, improved description is still based off this old commit here, right? And if you look, how can we, if we set master back to here, then it won't include all of these changes. It will only include these 7. So how can we get it to include all of them? Well, you can't do a fast forward merge. You have to do just a regular old merge. And so what this looks like, so we're still on master. So let's see what happens if we merge improved description. Okay, so what happens is it creates a new commit that has 2 different parents. So it combines, basically this commit points back to here and back to here. And then that's the new commit. And so the problem with this is, in this case, it was very, like, it makes it seem very simple. Like, oh, obviously it just combines the 2. But what will happen is fast forward merges, if you do like with button improvements, fast forward merges will always apply and you'll never have to do anything manually. It will just always work. They're great. When you have a merge like this, where you actually have a merge commit, right? Right here, this latest commit is a new commit saying how these were merged. It will take the code here and take the code here, and Git will try to automatically combine them. But there's a fair chance that this just won't work. And I'll show you, let me do a quick demo to show you how that could happen. So let's make some changes that are not going to be able to be reconciled. Let's see. Oh, our console log never got removed. Oh, you know what we probably have to do is, well, we can't rebase it now because it's pushed. So probably just make a new commit to remove this. Sometimes that happens and then you can't go and rewrite history to fix it. Okay, so let's create a situation where we have different changes. We have 2 branches. So let's, in this branch, let's improve our weather data. So instead of weather just being a state name, let's make this whole thing an object that has some other factors on it as well. So like a high and a low temperature. I happen to know that you can get these values off of this object like this. Okay, and now when we try to display this, it's not going to work. So what we'll need, because you can't just display an object. You can display a string, but you can't display an object. So we'll need the typography element in order to actually sort of display some of these. So let's take a look at what that looks like. All right, so we want to do, let's do weather dot weather. So in this case, when you make an object in JavaScript, you can now access, we should probably call this like weather object or something, just to keep it different. You can access those properties like that. It's a lot like making a struct. Okay, so let's actually look at this and see if this works. Close some of these things. Okay. Okay, there you go. So you get all the different things printed out. That's pretty nice. All right, so let's I think that's pretty good. Add those changes, commit those changes. Okay, that's great. And also, you know what? I just thought of another improvement. We probably should put a little degrees so that people know that it's degrees. Oh, and also, I don't think these are actually Fahrenheit either. Yeah, because I think this is San Francisco. And those temperatures seem kind of low, right? So I think they're giving it back to us in Celsius. So what we could do is let's fix it to do Fahrenheit. So anyone remember the Fahrenheit to Celsius conversion offhand? If not, I can look it up. Times 9/5 plus 32. Okay, thank you. Is it 9/5 or 5 nines? I think it's 9/5. Or is it 5? Yeah, it should be 9/5. Because it should be getting bigger, right? Not smaller. Yeah, I think you're wrong, Kate. Okay. We'll try it. Let's just try that and see if it looks right. So we can actually, it's probably better if we fix it here, right? It doesn't really matter. At the end of the day, this isn't super important. It has nothing to do with Git, but we need some changes to sort of demo so you can sort of see in a real project how you do this. Okay, let's see if that fixes it. Okay, much better. This kind of sucks, but we can fix that with math.round. Okay, try it again. Ah, very nice. And that seems about right. We also probably should say high and low. Okay, yeah, oh, now it's fixed. Okay, great. So these are some great changes, right? So let's add those. So what would we call this? Maybe, I guess this would be add temperatures to output. Okay, now let's go back and make another branch. So, oh, what we should have done is made a branch before that, but we can go back. So if you want to go back just one commit, so you can do it this way. This is one way you can do it. That'll take you back one commit. All right, you can see we're now at this add high and low temperatures. Whereas in the real log, there's this add temperatures to output. What you can also do is head. So you can check out head, but of course this does nothing. We're already there, right? If you do a little tilde after it, that will take you back one commit. So I use this frequently. And so this can be good. That way you don't have to go look up what the hash is, because that's kind of annoying. All right, so we go back one commit, and let's say we made a branch here. What I should have done is made a branch here. So let's call this branch, I don't know, card improvements. So now you can see, okay, head is pointing to master and card improvements is back here. Like say someone else had split off this branch. Normally, like you would never do this to yourself. But sometimes, master might be moving ahead with other people. If you work in a group, right? Master's commits are going to keep moving ahead with other people's merges, other people's fixes, other people's changes. And you might be working on your branch for a week or 2 weeks or at least a couple days, right? And stuff can change. And so let's say someone else is doing those other fixes. We're sitting back here on card improvements and we're going to make some improvements to the card. So look, okay, now you can see all that temperature stuff that improved it, it's all gone. We just have high and low printing out the bad way. And let's say we want to improve sort of the display of this card, because honestly, it doesn't exactly look great. Okay, so let's see how I did this before. What we can do to our card, we can set an elevation. And I set it to 3. I must have thought that looked good. Yeah, so that gives it a little more defined shadow. I think that's nice. Let's also let's see if we can sort of compress this down. So we do that. Hopefully that will, oh, that doesn't make it take up any less space. Oh, we need a box. Nope. So we just want to sort of improve. So we'll make another box to hold this. Oh, that's interesting, but not quite what we want. Let's put a line break in here. Okay, there we go. So now we have it sort of is a little smaller. That's better. Let's also make it so that instead of just the one block, the one box, we get one for each part of this data. So what we can do for that is map over our data. So map is just a way to I'll leave that for now. Map is a way to act over a whole array. So if we want to take, because remember how we're taking just that first day? What if we want to have a box for each day? So we can remove some of this stuff. Or I guess the only thing we need to remove is this. Okay, have that. And then what you do is you just return the object that you want. So whether high, low. And then the result of this whole mapping is an array that has all the data. So like we can actually look at this and see what this looks like. You can see why this is what we want to do. So if we search for this now, no, well, that's not good. Whether data is not. See, this is why you test before you commit. Whether data is not. Oh. You change these. Okay, try it again. Whether data map is not a function. Oh, I think we need to grab the consolidated weather first. Yeah, that's the problem. Sorry about that. This one should actually fix it with any luck. Okay, there we go. So now we see we get this array of objects that has, so you can see all the different weather states that you get throughout the day. That's great. Okay. And so now inside of here is going to be, we want to set our weather equal to that. So weekly weather data. So now weather is going to be, this is going to be like the weekly weather. And down here, now we're going to have to do another mapping to sort of make one card for each week's weather. So let's actually put a little margin around our box here. So what we can do is another map. So take our weekly weather.map. That in here. Unexpected token. Why are you angry? Oh. Okay. Let's try that. Weekly weather.map is not a function. Oh, yes. Okay. The other thing we need to do, so we start out, this should really be starting out as like an empty array instead of a string. Since now it's supposed to be an array. So this in the use state, this is a side note, not to do with Git, but in use state, you want to pass the default value. So it was a string before, but now it's an array. So we need to put an array in there. Okay. So let's type something. Okay. I think these are just errors from before, hopefully not from this time. Yeah, okay, we don't need to worry about that warning. Okay, so now you can see displays for each. Remember, this problem isn't fixed in this branch because we forked off before that got fixed. So you can see how this is going to cause a problem when we try to recombine it because we both changed the same thing. But for now, we don't even know that this other person has made these changes. So you know what? We're very happy and proud of what we've done. Let's see, this we don't need. Okay. So let's add that. Let's commit that. And okay, notice we're currently on card improvements, right? So it's going to commit onto the card improvements branch. So we can actually use the visualizer to sort of see this so you can see what's happened. So add support for multiple cards. Okay. So we now have these multiple cards, and this is great. So let's go back to the visualizer so we can sort of see what has happened here. Come on. Oh, there we go. All right, let me just add a commit there. All right, so what we did is we had a branch, and we called this branch, what was our branch called? Card improvements. I'm just gonna call it card to keep it shorter. All right, then we continued to make changes on how many did we make? So let's flip back to master and see. We just added one. Okay, so we added one change to that, and then we went to this branch, and this usually, again, this would be multiple people, and we made a change here. So this is where we currently are. So you can see, okay, how are we going to combine this? Because they both have two different histories. So remember, we just use git merge. And it makes a new commit that combines both of them. But what does this actually look like? Well, so we go to master, let's try it. So merge our card improvements. Okay, so it will try to auto merge it. Sometimes this works because if you touch different files, say, okay, like if we both did an edit app.js, then it would be fine. Or even if you edit different parts of the file. So like if one person only edits the top and one person only edits the bottom, there's a fair chance that Git will automatically be able to merge it for you, which is cool. But if you change like stuff that is kind of intertwined, like we did, right? We both changed the card. One of the changes is to sort of improve the card to have this high and low. One of these changes is to make it so that there can be multiple cards, right? These are both sort of, they're related to the same line, and Git doesn't understand code. Okay, Git does not understand how your code works. It only understands raw text and diffs in raw text. And so it's trying to do it like a textual comparison. So if you change the same lines, Git just can't figure out. I mean, it's hard for a human to figure this out too, because you have to kind of think about what it needs to be. So the way you fix this is you just open it up and you go to all of the conflict markers and resolve your changes. So you kind of have two main sections. You have this section here, everything from that head with the less thans to the equals. And then you have from the equals down to card improvements. And what this is talking about, head, remember, is where we currently are. And remember, what branch were we on? We're on master. So this is the main branch where we made the improvements that added the high and low and the degrees Fahrenheit and our 2 Fahrenheit. Like, so you see here, this is a great example. 2 Fahrenheit we didn't modify anything up at this part of the file in our other set of changes. So it doesn't make any conflict markers. It just plops that right there. Git figured that out. What Git can't figure out is some of this other stuff that we did. So here's what this actually means. The stuff in between here is what is on head. So it's saying, look, everything down here it auto merged or was exactly the same until here. And it says head has this. So you got this weather and then you did set weather. And then card improvements had this, but I couldn't figure out how to automatically make this work. And so what you do is you just deal with this whole block and you make it whatever it should be. And sometimes that means just taking this and deleting everything else. Sometimes it means taking this and deleting everything else. Sometimes it means you want to have both. Like if you have imports, right? If one person imports, A, and then another person imports B, sometimes Git will give you a merge conflict. Well, you probably want both things imported. But But so it really just depends on the case. Like in this case, we don't really want both of these things. What we want is sort of a combination. So we want this mapping behavior, right? We want to be able to do this with the array, but what we also need to do is add this to Fahrenheit here. Right? Because that was really the big change that was made here. And then do we want set weather or set weekly weather? We want set weekly because it's going to be weekly now. And you can see it actually ended up taking that change already from up here. So that's good. Is there anything else we need from here? Let's see. I don't think so. Does that make sense to people how we're actually resolving this? Because this is one of the hardest things with Git, is figuring out how to resolve a conflict correctly. So do people sort of see why in this case that is the right way to resolve it? This is probably the hardest part of using Git, honestly, is doing merges and dealing with the conflicts. Okay, we have one person saying yes. Okay, hopefully the rest of you also sort of see. If you don't, we're going to do another one right here. Maybe you can see again. Okay, so our head master has this, and notice remember the big changes we made there was to add this high in the degrees Fahrenheit and this low in the degrees Fahrenheit. And then our other one, remember, has this sort of map thing with the line break. And so we have multiple different ones. And so what we want is we basically want we want these from here. So let's put those here. We don't want these anymore. But then we basically want everything else from this bottom one because we're still going to stick with the weekly deal. So we want the break. We want all that stuff. Okay, so we can get rid of this. We don't need that. Delete this. Okay, and that is the resolution there. Does that help anyone else who is maybe still confused, or does that make sense to everyone as to how we resolve that? So we want to keep both things. And this is just, you have to do several merges to sort of get an idea of like what you need to do. But the idea is you need to think about one branch and what was really the big changes that happened there. Think about the other branch, what were the changes that happened there? And then think about, okay, how can I take those two separate universes and make a new universe that has the correct, like what the content should be after both changes. And so it's one of the hardest part, like resolving merge conflict, like you're not going to be able to just, maybe you will, but it took me like almost a year before I was able to like kind of sort of understand how to properly do merge conflicts. And you can still get some horrible ones. Git doesn't always do the best job, but hopefully you get an idea of this. Oh, okay. Question. Yes. How do you let Git know that you've made the corrections? Yes, that's what we're about to do. So if you notice, we're in this like quasi, like not actually on any commit, we're in this merge status. If you run Git status, you'll see you have unmerged paths, and you fix conflicts and then run Git commit. And then what you actually need to do is, before you run Git commit, is do this Git add. So to mark resolution or to say that you fix the file, because there could be problems across multiple files. In this case, we only have one file. That file had conflicts. But you could have 10 files, 5 of which had no conflicts, and 3 of which had conflicts, and then 2 that were deleted or something. Like there could be any number of files that are dealt with in a particular merge. So what you do is you fix the conflicts, and then you run Git add on that. And then all you need to do, it'll clean up this. It'll say, okay, all conflicts fixed, but you were still merging. And it only says this because you add it. So you have to like actually fix them. If you just add it, it won't work. It's not magic. It assumes that if you do add, then you know what you're doing. And then you just run Git commit. Now, Git will provide you with a default commit that's just merge, branch, whatever that is. Usually this is fine. If you want, you can change it, but this is sort of the convention is just to leave it as what it is. Something else I didn't show you before, but that you can do with this sort of long commit is add more. You can do this on any commit, but merge commits especially are a good one to do it on, is add like a more detailed description. So this can really only be like 80 characters or so. Do you see how my editor stopped syntax highlighting it after 80 characters here? That's because on GitHub and most other platforms, that's only how many characters they display. So we'll cut off your commit message at that point. And so you probably should stop typing after that point. If you're doing longer, it's going to look bad because platforms will cut it off. And you just don't want that to happen. This is supposed to be a very short, like high level summary. If you want to like give extensive detail about what happened, you skip one line. And then on line 3, you can type all the things you want to type. So say, and there's no convention to what you put here. Just describe your changes in detail. You know, you can do paragraphs, you can write a whole book, whatever makes you happy here. I might say something like combines. I combined this. There's no convention for tense down here. Mainly the tense convention is just for your short commit message. This you can use whatever. Okay, so I combined changes to cards. The card section. Had conflicts. Now the temperatures display in Fahrenheit and multiple cards display. Okay, so then you just save this and there you go. And now if you look at our history, oh, by the way, I should mention how I'm doing. So this git L doesn't work in regular Git. This is actually just shorthand for this. I have an alias set up for this in my configuration. But if you run this, you'll get, if this git log -- one line, that's what makes each commit one line. Graph gives you, look, you see how it gives you a little graph? So you can see like, okay, this commit was on one branch. This was, I think this is super cool. Like, I don't know who implemented this like ASCII graph thing, but I think this is like one of the coolest things. And then decorate, I forget what that does, but I think it just makes it look pretty or something. I guess it looks the same without it. Decorate makes it look pretty in some cases, I think. Okay, so you can see what happened. We had the one commit here, we had the one commit here, and then we merged. Now notice, after we do the merge, master is now on this merge commit. Card improvements is still back one commit. And you can see that from our, right, this is our sort of visualization. So that was the merge. That commit contains how to fix all the conflicts. Master is now there. Card doesn't move as a result of this. So if you want to catch up card to here, you can just go over to that other branch and then merge in master. And this is just a fast forward. And you see why. We can sort of look here, but you can see how the conflicts are already fixed. So doing that is just a simple matter of moving the head pointer. Okay, that was sort of the merge demo. That's how you do a merge. That's what happens when there are conflicts. That's how you fix them. That's pretty much all you need to know about Git. There's a few more things I'll touch on here and at the remainder end of our time here, but that is the majority of the stuff that you like need to know. Okay, we have a question. Is there a way to catch your branch up with the main branch if your branch is behind? Like if you branched a long time ago and never made any changes, but now you want to catch up before making changes. Yes. So yes, what you're describing is another use case of Git Rebase. It's dangerous. So let me show you what that looks like. How do we, Oh, that's not what I want. I just want to get back to, yes, I want to erase all of our progress. Isn't that just a fast forward? Maybe, it depends, but if you've already made some changes, you'll see why it's not a fast forward. Okay, so let's make a commit. Let's say we made a branch here. Oh, we need to actually make. By the way, if you just type git branch, it will show you all of the branches you have. You can also do git branch -a to give you all the remotes as well. So any server branches, it will show those too. And it shows you a little star for the one you're on, and it's all nice. Okay. But if you want to actually make a branch, so you need to type the name. So git branch, we'll call this like, I don't know, what's a good name for this? Old. Like this is a branch that we're going to like make one commit on and then kind of forget about, right? That's what you're saying. It's like, what if master has like really moved ahead? So you made one commit on this, and then meanwhile, go back to master. Master has like really been doing stuff. This is what you're talking about. Is this what you're talking about? Please confirm so I don't waste too much time with this. This is what you're, okay. Yeah. So you made like one commit a long time ago and you're like, ooh, master is just going ahead more and more every day. I don't want to like deal with this disastrous, because if you wait, I knew a guy who would like wait like a few months before he would make a merge. And like the code, the master branch had changed so much, like it was almost impossible to merge his code in because like a lot of it just didn't work anymore because so much stuff had changed. So you don't want this to happen. Try to avoid this happening if possible. But if it does happen, okay, how can you fix this? And maybe let's go back to old and like add like one more commit so it doesn't look so sad. Okay, so we made like a few commits here, but like it's been a while, or master's just really active. A bunch of things have happened. How can you fix this? Well, the answer is without changing history, you can't fix this. One thing you can do, if you've made like very simple changes and you want to be like absolutely safe, you could just go back to master, make a new branch, and then like redo your changes. Oh, that's not what I wanted. Okay, but like you could check out, you could basically just like manually redo your changes, right? So make a new branch and then make changes, and then just do a regular merge. So this is one thing you could do, and then just forget all about this because you can delete branches. It's just git branch -d. But this is maybe not the best solution. So what you can do instead, let's go back to commits. Okay. Oh, you know what? That's not what I wanted. Sorry, I'm just trying to get it set up back to how it was before. So reset hard is a way to like perma set your branch back to a certain point. But watch out, because like you see these commits that I made and I reset it hard back, so they're just gone forever. They're not actually gone forever, but it's very hard to get them back. And then let's get rid of old 2. Okay. So just pretend those aren't there. I don't know why it persists them for the visualization, but let's say that never happened. So we're back to here. How do we fix this? Do you see how we can't do a fast forward because these 2 commits won't be included? There is a divergence. It was just very long ago. If you're in this sort of situation, one thing you can do, so sort of the safe thing to do, where like you're not going to break anything, even if you're not too sure what's going on, you can merge in the master branch. Okay, so you can merge in the master branch. This is, I think, the most common way to deal with this. So you go to your other branch, merge in master, fix all the conflicts, and now you're good to go. Master can keep going, right? So if we go back to master, you're basically up to date with master at this point, and master can keep heading off, doing its own thing. And then if you're ready to merge in the latest changes, you can merge in master again. Well, okay, let's say you made a commit and you can merge in master again. And then someday you can finally merge master back in. And then it'll be fixed. This is one way to do it. This is the way many teams do it. It's a very common way to do this, and it's not a bad way to do it. It preserves the real history of what happened, as messy as this may be, right? You might be like, okay, this is kind of messy, like there's all these arrows pointing everywhere, but this is what really happened. So yes, maybe you like this solution. Okay, this is a fine solution. There's another way you can do this. And this would be with Git Rebase. This, however, you have to be careful with this because it has all the same caveats as Rebase from before. So make our commit. All right, we make our branch. All right, and then let's see, let's add lots of commits for master. The other thing you can do is use Rebase. And what Rebase does is it lets you rewrite history to make it seem like the commits happened in a different order. So what we can do is say, okay, instead of these two commits that are part of old happening based on this commit, right? We really branched here on commit 37E. But what if we want to say that we branched here? We want to be updated. We want to say that these commits actually happened like right now. Well, what you can do is check out the old branch and then rebase it onto master. So git rebase master. It will take any commits that are different and then copy them up to here. So do you see what happened? Okay, this is kind of complicated. And this is why people usually just do the merge way, because it's less confusing. But what happened is it took those commits and rewrote them. It did the rewriting history thing to make them seem like they happened based on the latest master. And now, if you want to merge, you can just do a straight fast forward merge. Also, if you do this continuously, let's say we go to master now. What you can do is, and a lot of organizations do this for various reasons. Sometimes rebasing all the time is easier than trying to do merges. Especially, it comes most in handy when you make a small number of changes and the master branch moves very frequently. If you only have a few changes, it's a lot easier just to rebase those changes onto the latest master than it is to have a million merges like every 2 weeks or whatever. And then, so then we can go back to old, rebase that onto master. And so it'll make it seem like these commits never happened. And then it will reapply them here. And then whenever you're ready and you're finally ready for this to get merged in, you can go to master and you can merge in the commits, and then you just have a straight fast forward. And here's what's nice about this. Remember, these commits are gone. They're deleted. We pretend like they never happened. So our history is completely linear. There are no branches. There are no forks in the road. It looks like everything happened in sequence. And this, some people really like this property. It makes certain kinds of things easier. There's a git command. I'm not going to go over it today. Maybe at a more advanced workshop. But there's a command you can use to do a binary search of all your commits to figure out which commit caused a bug. And if you have a bunch of merges and a bunch of branches and forks, it's harder to use that command. Some people just like the way this reads because the logs, if you try to read the logs for one that has a million branches in it, it is more complicated because you have different things happening different times. Whereas this, you just get a linear history. So some people really like this. But what you have to be careful of if you do this, so let's go back. What you have to be careful of if you do this is that no one else has forked off your branch, because I'll show you why. And this is why Rebase is dangerous. Okay, so git commit. Does that make some sort of sense though? Like what Rebase is and why you might want to do it? Not that you should do it, but that's why it exists. It is literally for that use case. So that's all fine and dandy if you are the only one who knows about the old branch. So if this is like your personal branch, it's in a private, or it could be public, but you're just sure no one else has looked at it. Like if really realistically no one else has looked at it, it's probably okay. But I always try to just keep it confined to only private branches that only I know exist, or only on my local machine, or only I know that, because then you can rewrite history. No one will know you rewrote history. It's fine. As soon as you publish the history, if you try to rewrite it, other people will still have the unrewritten history. You have horrible conflicts. It's a disaster. And so here's what that looks like if you try to do that. So let's say we go to old. Let's say someone did know about this and they made their own branch old improved. So you push this. Let's see. Oh, it didn't. Dang it. Old improved. Oh, typos. Okay. Finally. All right. So, and they've made some commits based on your old improved. Now, let's go back to old. You don't know about this, or you don't care. You're like, you know what? I love Rebase. Linear history is the best thing ever. I don't care. It's public. It's fine. You rebase onto master. Okay. So this looks okay, but now what will happen to old improved? If we go back to old improved, now if they later merge, so it's not so horrible, but what will happen is when old improved merges into the current master or the current old, these two commits are going to be duplicated. They're here, but they're also here in the other history. What you can do is you can rebase old improved onto master. And Git is actually, in most cases, Git is smart enough to dedupe. So this actually isn't what will happen. Git is smart enough to deduplicate these commits that are actually the same commits. But this is definitely a sketchier idea, because if there's no way that they could know that you had rebased. And so it's going to lead to this bad history situation where you have two copies of the same commits. So this is why you shouldn't rebase things that are public, unless everyone agrees to abandon the old branch and rebase, which is hard to do if you've made something public, because who knows who's looked at it. Just as common courtesy, don't rebase things that are public. That's basically just the rule. But otherwise, I would say it tends to look cleaner. You get the linear history. So if it is private, I tend to prefer rebase. If it's public, I always merge. And that's one reason I actually don't always push so much, so that I can rebase. Okay, hopefully that makes some sense. All right, we're nearing the end of our time for this workshop. I know we didn't get a whole lot of the app finished, but we got enough to sort of see how Git works. And this really wasn't about building the app. I encourage you to check out this tool for visualizing it. And there's one more thing we probably should talk about, and that's polling. So Git pull is the opposite of push. You take changes from the remote and merge them into your local branch. So let's actually just use the tool. Might be easier. All right, so let's say you made some commits, right? So we made a commit. We can see master still back here. When we push, it syncs that commit up to our origin. If origin has commits made on, so you never should check out origin and do this. And in fact, this doesn't actually show what I wanted to show. But if you can kind of get the idea. If commits are made on the remote branch, they should be showing up over here, but it's not doing what I want. Then you can run git pull, and that did the right thing. Okay, I'll just show you on this. So let's push up our changes. What does our log look like? Is this all fixed? Yeah. Okay. So let's check out master. Let's push up our changes. Okay. So let's say, does someone else want to add a change to this? I'll add someone else to this repository and we can sort of see that. Otherwise, I can just do a change via the web interface here. I'll just do that. It'll be easier. Okay. So, but think about this like someone else making these changes. You're collaborating, someone else does this. Okay. So on GitHub, someone has made a change. Let's say, I don't know, they just decided to swap the order of these two things, something silly like that. Doesn't really matter too much. It's not important for, okay. So they decided to swap the order. I guess that makes more sense, right? Low then high, high then low, I don't know. Okay, so then they make this commit. So this happens, you pretend someone else did this. So now think about the situation, okay? The server has changes that we don't. So it may show your origin master being local, but that's only because you haven't fetched. So what Git Fetch does is, because remember, any branch that you're able to edit, like an origin master you're able to interact with, is on your local machine. So origin/master is just a mirror of what the real server's master is. They are still technically separate. To sync them, you can do git fetch all. And then if we run the log, you can see, oh, look, it's gone. Well, where did it go? You can see, okay, origin/master now has those changes. We do not. And so in order to actually get these changes, if you're on master, and actually if you run git stat, so if you run git fetch --all and then run git status, it will tell you to do this. Your branch is behind origin master on commit and can be fast forwarded. That's a fast forward merge. Sometimes it can't, because if you made commits and then master made different commits, then you can get merge conflicts when doing a pull. If you only want to do a fast forward, I highly, highly recommend that you run this before you run git pull. Try to do it fast forward. If it doesn't work, then you need to think about what you need to do before you just go git pulling. You might want to merge, you might want to rebase. You can do git pull rebase. That will rebase your changes. It will take your changes, pull the ones from the remote, and then rebase yours on top of that. Regular git pull just does a merge by default, and then git pull ff only will only do a fast forward. So only if it cleanly applies, otherwise it will just fail. So I strongly recommend you try this first. You run that, it will merge. In this case, only do fast forward merge, and then head, master, origin master. Everyone is all up to date on this, except card improvements, who's still back there. Yeah, so that's git pull. Something to think about, but that's another collaboration thing. So you push to move your changes up, pull to get your teammates' changes down. And you might get merge conflicts while doing this. And if you do, you need to look at them, figure out what's going on, fix them, maybe talk to your teammates too, because if it's code you're not familiar with, you might need to talk to your teammates to figure out what to do. But that's Git. That's basically day-to-day. I mean, you see, that's the majority of the commands that there's a couple other ones, of course, there's always more to learn. But if you can do all the things that I showed you today, you're pretty much like professional level of Git. Do we have any questions? If there are ways to access this recording, there will be. It will be on the YouTube within the week, usually within a couple of days, but sometimes it takes a little bit longer. It will be uploaded to YouTube, yes. Anything else?